For understanding the deviation of light that is produced by a triangular prism, let us consider the following activity. Here I have drawn a triangular prism surface A, B and C, where PQ is the incident ray at the point Q, where I have drawn a normal, and if we were to mark the angle of incidence, it would be this angle, and I am representing it by a small I. Now, if there was no change of medium, that is, if the light was traveling in the same medium, then the ray PQ would have been traveling in the straight line like this. But as it is moving from one medium to another medium, what happens? Refraction takes place and the light gets deviated, the path of the light gets changed. So what happens is the ray PQ, after getting refracted at the surface AB, moves in the direction of QR. So in this case, I am going to mark the angle of deviation, like if the ray was traveling in the same medium and after the refraction the path changed or deviated is this much, I am going to represent it by delta 1. Now for the surface AC, QR is the incident ray, and after refraction the ray travels in the direction of RS, that is the emergent ray. RS is named as emergent ray. Now again QR, from QR to RS, it is changing its medium from 1 to 2. So what happens again? Refraction takes place. So if there was no change of medium, then the ray QR would have moved in the straight direction like this. But as it is traveling from one medium to another medium, there is a change of path and there is a deviation, and let us represent it by an angle. It is deviated by this much of angle, and let us name it as delta 2. So in total, the angle between the incident ray, that is PQ, the incident ray PQ, and the emergent ray RS, when extended in the backward direction, if you extend the RS in the backward direction like this, you will find the total angle of deviation. That means the total angle between the incident ray and the emergent ray, and it is represented by a delta. Numerically, delta, the angle of deviation, is equal to the summation of delta 1 and delta 2. The total angle of deviation in case of a prism depends on three factors. The first one is the angle of incidence at the first surface, that is this angle. It is dependent on the angle of incidence. Secondly, it depends on the angle of prism, that means this angle that is made between the two refracting surfaces of the prism, this angle. It depends on the angle of prism. And third, it depends on the refractive index of the medium that you have used, in this case a glass. Also, it depends on the wavelength or the color of the light that you have used. Till now, we have only established the relation between the angle of incidence, the angle of prism, and the refractive index of the material. Now, we are going to establish the relation between the wavelength as well as the deviation that is produced in the case of a triangular prism. Let us talk about the dependence of deviation on the color of the light or the wavelength of light. When the light of different colors are traveling through vacuum, they have the same speed. That means all the different wavelengths of light have same speed when they are traveling in vacuum, or ideally we can say that they have same speed in air. But whenever it travels from one medium to another medium, that is from, in our case, from air to glass, the speed of the light changes. And whenever the light that is traveling into the prism is not of single color, let us say that in our case there is white light traveling or incident on the surface AB of the prism. Now white light is not of a single color, it is composed of 7 different colors, as we know. So whenever the light is emergent on the other side of the prism, it is arranged in an indefinite order, because the speed of light in transparent medium decreases with the decrease in wavelength of light. The speed of the light decreases with the decrease in the wavelength. Now, when does the speed of the light decrease? When the refractive index is more. So we can say that as the refractive index is more, the wavelength decreases. So the deviation that is caused by a prism also increases with the decrease in the wavelength. As the wavelength goes on decreasing, the refractive index increases. In case of visible light, the violet colored light is deviated the most and the red colored light is deviated the least. When a white light is entering a prism, what happens? It gets divided into 7 different colors, the 7 constituent colors. We know it as Vibgyor: violet, indigo, blue, green, yellow and orange. So it starts with violet and then it goes till the red color. So we can see that the violet colored light is bent the most, that means it is deviated the most, whereas the red colored light is deviated the least. From this we can conclude that the velocity of the red colored light is more and the velocity of the violet colored light is very less. So if we relate the velocity and wavelength, we can say that the wavelength and the velocity of the red light is the maximum, whereas the velocity and the wavelength of the violet light is the minimum, is the least. The white light that is emitted from any source consists of light of different wavelengths or different colors, as we know now. The light of different wavelengths produce the sensation of different colors on the retina of our eye. So we perceive them as different colors. The different colors differ in their wavelength. The wavelength changes, and in fact the wavelength is the characteristic of color irrespective of the origin. That means what? If there are two different origins of light which are emitting the same colored light, no matter what the frequency is, if two different sources of light are emitting the same color of light, then the wavelength of both the sources of light is same. In other words, color of the light is subjective property of wavelength. That is, a wavelength is the characteristic of color. The splitting of white light into its 7 different constituent colors was found by Sir Isaac Newton while he was studying the image of a heavenly body that is formed due to refraction of white light by a lens. He found that the image is colored at its edges. Then he thought that the colored image is due to some kind of defect in his lens that he is using. He then repeated the experiment with a carefully polished lens, but still the image was colored. Then Newton concluded that the fault is not with the lens, but there is something in the nature of white light itself due to which the image is colored at its edges. For his experiment, he took a triangular prism and white light, as shown here, was incident on the surface AB of a prism. Then on the other side, he observed that the white light was dispersed or separated into its constituent different colors, starting with violet till red. The light emerging out of the prism was received on a white screen, and on the screen a colored patch like rainbow was shown, as it is shown here in the figure. And the colors, the patch of the colors altogether is named as a spectrum of colors. And the order of the colors in the spectrum can easily be remembered by the word Vibgyor. From this experiment, Sir Isaac Newton concluded that white light consists of 7 prominent colors. Each color corresponds to a small range of wavelength. Thus, the white light is a mixture of large number of wavelengths. So, it is also known as a polychromatic nature. The splitting of the white light in 7 constituent colors, in 7 different colors, is known as the dispersion of light, and the band of 7 different colors is known as the spectrum. Now, why does this dispersion occur? The dispersion of white light is because of the change in the speed of light with wavelength. When light travels from one transparent medium to another transparent medium, there is a change in the speed, or there is a change in the wavelength of light. When white light enters the first surface of a prism, light of different colors due to their different speeds in glass gets deviated through different angles towards the base of the prism. That is, the dispersion of white light into its constituent colors takes place at the first surface of the prism. The violet color is deviated the most and the red color is the deviated the least. Therefore, light of different colors follow different paths in glass and then strikes the second surface of prism. On the second surface of prism, only refraction takes place and different colors are deviated to different angles. As a result, the color gets further separated on refraction at the second surface, and the light emerging out of the prism thus has different colors that spread out to form a spectrum on the screen. Now there are a few things that we need to keep in mind, that is, the dispersion of white light occurs only at the first surface of the prism. The deviation of light occurs at both the surfaces of prism, and the prism does not produce colors, but it only splits the various colors that are present already in the white light that is incident on it. So this is it about the deviation, dispersion and spectrum. Thank you for watching and thank you for your time.